This video is for class 9 physics and we are doing factors affecting the speed of sound in a gas. In the same video we shall also discuss about the factors not affecting the speed of sound in a gas. So let us begin. The speed of sound in a gas is affected by the change in density. Number 2, temperature, right? Density, temperature. Then the third one, humidity, and number 4, direction of the wind. Let us discuss these all points one by one. The first one being the effect of density. From the relationship V equals to under root gamma P upon rho, it is clear that V is inversely proportional to the density. In fact, we can say V is inversely proportional to the square root of the density. So the density of the oxygen is 16 times the density of hydrogen. Therefore, the speed of sound in hydrogen becomes 4 times, because the square root of 16 is 4 times the speed of sound in oxygen. So here what we learn is the speed of sound is inversely proportional to the density, right? The next factor is the effect of temperature. Now the speed of sound in a gas increases with the increase in temperature of the gas, that means temperature of the medium, right? This increase in temperature is not because of the propagation of sound. This increase in temperature is because of the external factors. Okay, so the reason is that the increase in temperature, the density of a gas decreases and consequently the speed of sound increases. So as the temperature increases, volume increases, therefore the density decreases, right? So when the density decreases, as you all know from the first point, that the speed of sound increases. So it is directly proportional. In fact, the speed of sound is directly proportional to the square root of temperature of the medium, right? So the speed of sound V is directly proportional to the square root of the temperature, where T is the temperature of the gas on the Kelvin scale. Now the speed of sound in air increases by 0.61 meter per second or 61 centimeter per second for each degree Celsius rise in temperature. Okay, each degree Celsius rise in temperature, provided that the rise in temperature is not very large. Okay, then it becomes like then this formula is not valid. Okay, for a moderate rise in temperature. Okay, so in that case we can write Vt equals to V0 plus or V0 plus 0.61 T, where Vt represents the speed of sound at the given temperature, that for example 25, 26, 28 degrees Celsius. V0 denotes the speed of sound at 0 degrees Celsius, and 0.61 from here it comes from the experiment and multiplied by T, which is the temperature of that medium at that instant. Okay, example, the speed of sound in the dry still air at 0 degrees Celsius is 330 meter per second. At 25 degrees Celsius the speed of sound in this air will be V25 equals to V0 or V0 plus 0.61 multiplied by T. Thus by calculating we shall get 345.25 meter per second. I hope you have understood. With increase in temperature the speed of the sound also increases. Coming to the third factor, which is the effect of humidity. The speed of sound in air increases with the increase in the humidity in the air. The density of water vapor is 5.8 times the density of air at dry air at ordinary temperature. So this means the humid air, right, or we can say the moist air has less density, right? That is 5.8, which is less than 1. So the dry air is much more denser compared to the wet air, okay, or with the water vapor present in the air. So we can say the increase of moisture in the air tends to decrease the density of the air. Hence the speed of sound in the humid air is greater than the speed of sound in the dry air. In other words, the sound travels faster in humid air than in the dry air. This is just because of the density. So everything is boiling down to density right now, because in the formula we have density. Okay, now the fourth factor, the last one, the effect of direction of the wind. Now the speed of sound increases or decreases according to the direction of the travel of wind. If the wind is blowing in the direction of the propagation of sound, obviously it will help the sound, so the speed of sound increases. While if it is blowing against or in a opposite direction, right, to that of the sound, the speed of sound decreases. If v is the speed of sound in a still air and w is the speed of the wind, then the speed of sound becomes v plus w when the wind blows in the direction of the travel of the sound, and the speed of sound becomes v minus w when the wind blows in the direction opposite to the direction of travel of sound. So we can understand this with the help of an example. The sound of a distant music is quickly and loudly heard if it is coming with the wind. On the other hand, it is difficult to hear if the wind blows in the opposite direction. Okay, so I hope you have understood the factors which affects the speed of sound. Now we shall discuss the factors which does not affect the speed of sound in a gas. The first one being the pressure, right? So in the formula itself we have a pressure, but still they are saying us the speed does not depend upon this pressure. Let's see, right, how. The second factor is the amplitude of the wave. The third one is the wavelength or the frequency of wave. Now the effect of pressure. The speed of sound in a gas is independent of pressure. In the formula v equals to under root gamma p upon rho, although that p is pressure present in the formula, they are saying it is independent. The v is independent of p because the ratio p upon rho remains unchanged, okay, with the change in the pressure. So it's not only the pressure, it is the fraction, the ratio, right, which is helping the speed of sound to change. So if the pressure changes, so when the pressure increases, suppose volume decreases, as you all know, it gets compressed, but the mass remains unchanged, so the density increases, right? So if the pressure increases, density also increases. That means if this increases, right, this also increases. Suppose the original value of pressure is 5 and the original value of the density is 2, suppose, right? If the pressure becomes double, the density also becomes double. Let's see how, right? So for example, if the pressure P of a gas is doubled, the volume becomes half, so the density gets doubled because the mass is constant. As a result, the ratio P upon rho does not change. That means then that 2 and 2 gets cancelled, so it will be 5.2 again. If we take the previous example which I had written, thus the speed of sound in the gas is independent of pressure, right? Is independent of pressure. So I hope the point 1 is clear. Point number 2, effect of amplitude of wave. The speed of sound does not depend upon the amplitude of the wave. The loudness depends, but the speed of the sound does not depend upon the amplitude. Number 3, the effect of wavelength or the frequency of the wave. The speed of sound does not depend upon the wavelength or the frequency of the sound wave, right? It only depends upon that elasticity and that temperature, density, right, humidity, etc., wind and all, the direction of the wind and all, right? So this much for this particular video, right? Thank you so much. In the next video we shall do this comparison of speed of sound with the speed of light.